55 of Neetcode 150. Count good nodes in a binary tree. All right, so let's read the problem together. So within a binary tree, we are given a node x is going to be considered good if basically the path um, from the root to that node contains no node with a value greater than that value of that node. Okay, so let's say we first start with a root of 2 in this tree and we go to the right and to the left. Well, you notice that to the right and to the left we have a 1, and 1 is smaller than the previous value it came from. So imagine that I am a person walking down the path starting from the root, and then I see a value that, oh, it is less than what I used to have. Okay, so let's see this as a chronological timeline where you can only move forward in time, and a good node is basically a node where the number is greater than the place you used to be. Okay, so right, if you are at time 2, well, you can't possibly go to time 1 as you walk down the line, right? You can't go forward in time, uh, but still having a time less than where you came from. Okay, so this is incorrect, and starting from 1. Okay, if you go to 5, well, actually 5 is greater than 1, and it is also greater than 2. So what we really want to take into account here, it's what is the maximum value that we met in that path. And basically, we don't really care if there's a bad node in the path we came from. All we care about is that the value we are at is greater than the maximum value that we've seen so far. So 1, well, it is smaller than 2, right? Because at this node 1, when we go to the left, we've already seen something greater than 1. We've seen 2, okay? So this is not greater than 2. This is not a good node. 5 is greater than 1. It is greater than 2, so it is a good node. On the other example, well, on the other side, if we go to the left, we start at 2, we go at 1. This is less than 2, so this is not good. And then we go to 3, and we notice that the biggest value we've seen so far is actually 2. So 3 is greater than at maximum value we've seen so far, so it is good. Okay, so let's see how we can solve this. So for this problem, we are going to use depth first search in a recursion algorithm. So we are going to start from this node, and we are going to go do a recursion on each side. And let's say that we start here, so we go to the right, and we just put our focus on this right branch. Well, the maximum value we used to see, we saw previously was 17, which is the value at the root, right? So it used to be 17, but now we need something greater than this. So if it is greater, well, we actually are gonna have to increase our count of good values, because at the end we have to provide an amount, like a count of good values or good nodes in the tree. So we are gonna increment this count by 1, and we are gonna just set that the greatest value we've seen so far is 35. All right, so from this, so um, after this, once we go further down this branch, every single values has to be a good node. It has to be greater or equal than 35, which is the maximum value we've seen so far. So if we go to the right, we notice that 38 is actually greater than 35. So from this node, all the values down, if they happen to exist, have to be greater than 38, right? And on the left side, this 29, well, it is not greater, it is smaller than 35, so it is not a good node. All right, with that being said, let's go ahead and jump into the problem. So we are first going to have to call our recursive function DFS. So we're going to use depth first search DFS, and in this function, we are going to be given the node, and we are also going to provide the max value we've seen so far. So let's call this max so far. All right, and at the end, what we are going to return is basically the call of that function, where the node that we are going to give them is the root, and the value is going to be the value of that root. Okay, so when we reach the first node, well, we're going to have a value that is exactly the same, right? We're going to get its same value, so it is gonna count as a good node because a good node is greater or equal than the previous one you've seen so far. So first, what do we do if we reach the end of the tree, right? So both shells will be equal to none. So we have to ensure that if there is not a node, so if not node, right, we are gonna have to return 0, okay? Because notice that this function actually is a recursive function. So every time we go deeper in the tree using that function, we are gonna have to make these if statement checks to ensure that we are not returning a good node for a node that is set to none. And after this, we are going to have to ensure that we either return 1 or 0 for every single node. So what we're going to do first, we're going to set the result of that node to 1 and 1 only if that value is greater or equal to the max so far. Okay, and else we are going to return 0. So this is the entire logic, right? After this, we want to make sure that the max so far is going to be set to the maximum for this node. So if this node is not a good is not an actual good node, the max so far will stay the max so far. Otherwise, the max so far will become the value of that node. So node dot file. All right. And then this is where we are going to use our recursive calls. So we are going to, okay, so we are going to use basically this same res value here. And we are simply going to say that res is plus equal to that recursive call, right? And in this recursive call, we want to first set, we want to make one call for the right branch and one call for the left branch. So we're going to say node that left, given the max so far. And we are also going to do the same thing for the FS with node dot right and the max so far. Okay, so after this we can return res, and for every single recursive calls we are going to add to this res a 1, right, if it is a good node. Otherwise we are going to return we are going to add 0. So we are going to keep track of how many good nodes we have in our code, and then we are going to return it. And basically the return is the call of that function. So it's gonna give us an integer representing the number of good nodes, and we have an error here. So why is this an error? Oh, that's right. So I made a typo here. Sorry, instead of writing a comma, I wrote a dot. So let's see if this works. And yeah, it works perfect. All right, so I hope you learned from this video, and I hope to see you in the next one.